made a title which looked good, drone and mine rehabilitation on month drones, or they hate them, one of the two. Today I'm going to give a special emphasis on coal mine rehabilitation, because that's where a lot of our money early on came from to play with drones. Let's see if this works. May not. I'll do it this one. So as a broad outline, firstly, how do we determine whether a mine rehabilitation effort has been successful or not? I'm just going to give you a broad overview of what I think. Some issues about scale and how people have done it in the past. Then I'm going to talk about using drones, how we generate some data, and we try and couple it with field observations at the same time. Because many of the people doing rehabilitation or assessing rehabilitation are ecologists, which are quite different from engineers. It's a bit more free form. They like transects, they like plots, and they like looking at little plants, and they like other things like looking at soil. I'll talk a little bit about fire and why that's important, particularly in coal mines, and buffalo grass, which is a particular exotic grass that got introduced to grow cows. And it's on a lot of our coal mines in Queensland. A bit on biomass, remote sensing trends, and I'll just finish with some conclusions. So 12 years ago, I came over from the School of Biology. I had a position offered to me at Centre for Mine and Land Rehabilitation. It's a research fellow position, mainly funded by a BMA project. And it was to assess how the rehabilitation across the coal fields are going. Now, in the coal fields, there's about 100,000 hectares at this stage of rehabilitation, or, well, actually, not rehabilitation, sorry, take that back. 100,000 hectares of disturbance. Probably when I started, it was about 80,000. Now it's about 130,000. That's a good boom. Now, when I first went to a site, any of the BMA sites, actually any site in the Curragh Basin, you walk say, okay, let's have a look at your rehabilitation. Let's have a look at your spatial analysis of how you're doing. And what you find is that here's a mine where it's coloured in green. That means they've rehabilitated. Now, if you actually walk onto the site and you walk onto that rehabilitation, generally an ecologist will set up a plot, and it might be as close to the road as possible because they're worried about falling into a gully, or otherwise there's all sorts of safety restrictions on how far you'd want to let people go in. These aren't finished, so these are rehabilitated, but there's still, in most cases, there's still entries into the pit, so the ramps, so these inter-ramp areas are extremely steep. Because we've been digging downwards, these hills get bigger because they just push them up. And pretty much the pits always sort of go in the same direction, and rehab happens behind it. So then you ask, so this is what's reported. So there's always self-reporting in mining. And the best way to get your rehabilitation bond back, or most of it, is to say, I've completed. So completed means that you've done the landform shaping, you've run a tine or a rip through it, and you've sprinkled it with seed, and all as well. And you report that, and that gets rid of most of your bond, and you're left with about a 5 to 10% residual bond that the government will keep until you try and sign over the land to someone else. So this is what is reported. Green, it's done. The reality when you get on the ground is that, of course, it's a bit more complex. There might be a road access, there's some trees, there's some bare grounds, there might be a gully. Now, depending on what your final land use is, which mine companies like to keep fairly vague, because on one hand, in the Bowen Basin, most of the area was cleared, or a lot was, because they wanted to grow cows, and cows were a good option. When you leave, now, Bowen Basin is also mainly sodic material, so the soil is sodic. It's generally flat. The reason why it's flat is because it's dispersive. If it's dispersive, then you pile it up, it wants to be flat again. So gullies are a pretty common feature in coal mine rehabilitation in the Bowen Basin. So originally, in the 70s, they said, what we want is more place to grow cows. Fine. Now, what happens is, when you look at the landform and you've got it now 200 to 300 metres higher than the surrounding landform, and it's dispersive material, there's been, as far as I know, really only 2 experiments using cows on any of these steep landforms. They didn't work out very well because, as often happens, grazing, you get a loss of biomass, you get erosion happening, time to take the cows off. Not to say it can't happen anywhere, but it's just most of the landforms that have been created are not suitable for growing cows for very long. Might be able to do it with pulse. So then the mining company said, well, actually, what we want is native ecosystems there. Now, they didn't plan for native ecosystems. There aren't really any native ecosystems on sodic spoil piles, but it seems like a good option. So when I talked to them, who's going to take this? Well, national parks will want it. I don't think so. So we're in this sort of state. Got to take both the industry and the government along about what these areas can be used for. Now, the areas of interest obviously are quite large. We're talking thousands or hundreds of hectares at a site to thousands of hectares to hundreds of thousands of hectares across the whole Farm Basin. Now, the ecologists, they like to work on a, see that pink thing there? That's a transect, which is a standard size. And this is a typical post mine. There's a pit, and I've done a bit extra rehab here. It's fresh soil, topsoil, some established rehab. That's what it looks like. Now, when you go to a site, generally you can get some imagery maybe from Worldview. A mine site might supply that to you. I mean, mine sites are focused on production. They're not really that interested in what ecologists might think about their rehab. It's all right. So you might be able to get this. You could get this these days almost free, but when you see that transect, you can't actually tell too much about it. Now, if you're really lucky, a site will have 50 centimetre aerial photos. This is when I started, but they won't capture them very often because they don't have really any reason to capture their large lease at costing them tens of thousands of dollars, $15,000 to mobilise an aircraft. So we thought, well, drones are coming. Let's try and look at this with drones. Now, that's an image or a composite image that from a drone that we started flying in 2012, and as you can see, you can start to even work out, there's different species, different groups of species. You can tell the grass from the trees as such. So this is some of our early drones. This one's from New Zealand. It was used by the New Zealand military to target people in Afghanistan. We changed it to target rehab. We needed something a bit more robust because it was built in New Zealand, landing on soft grass. So the first thing we did was get a parachute installed. We also wanted near-infrared cameras so that we could look at vegetation health. And in the end, we came up with this beast here, which is swamp fox. We've flown that in Malaysia, and we've flown it all over the country, and it's quite robust. But it also is quite heavy. It's custom build, requires a big bungee to launch. We realised that there is some risk associated with that, so it's been discontinued currently. Went to Evie, which is a commercial drone, because of course I started this in 2011. The first thing we had was a crash cam, it was called crop cam. It mainly crashed rather than record any pictures. That's why I went to the more expensive New Zealand version, which would break wings very quickly, to that one, which really worked, but had some dangerous issues, potential dangerous issues. This one, it's less than a kilo. You can get a multi-spectral camera in it, but it's actually not that steady. And so more recently, we've got a M210, which is a DJI product, which is a commercially available, a bit more expensive. You can have a thermal camera and also multi-spectral cameras on it. So that's sort of how we developed. So the first thing that we could get when we got these drones, very exciting for us, went up to Collinsville, which isn't part of BMA, but they also gave us some money, and had a look at some of their rehabilitation there. Now, here, this is a landform which is of varying ages, and we can actually see, we walk out, we spray paint the ground, so we know exactly what we're looking at when we're looking at an image. So even though it's white paint and you probably can't see it, but there's a transect there, that's white marked every 5 meters. And with that sort of information, because you fly it in lines and they all overlap the images, you can use triangulation, or just a computer can, in a black box, and it'll work out the height. And so this is a digital surface model that's developed out of all that overlapping imagery. So you get an ortho mosaic, so that's all the composite of the imagery, and you get a digital surface model. You can drape that imagery over the digital surface model, and you can look at this beautiful landform, which has lots of gullies in it. Now, when we go back to historic imagery, we can see that this landform was built over about 6-7 years. In fact, this area, which has all these gullies, was built, I think, 4 times because they just kept falling apart. And when we were there, it still had a very large gully in it, which means there's a lot of extra work going on because people aren't keeping very good records of what's happening on their site. But we can map out where all the gullies are and where the problems are, and it's really related to slope, and maybe it's too steep for that material. Then we went to Curragh, which is a mine site in central Queensland. We've had long-term monitoring there for we've had it for 10 years, and we wanted to get a bit more sophisticated about it, and we said, how about we work with the drones? And they said, okay, we'll add an extra couple $30,000 into the budget, and you can go play with drones. Great. This is the imagery they gave us, and that's what we're working with. That's standard transect, 5 by 50 meters. Now, when we capture drone imagery, we can see a lot more about, well, what does the site look like. We can also monitor it over time. So that was 2013. Next year, measure many years in a row, so look at temporal change. And of course, people go, you can choose those transects randomly. And I guess when I came from biology, I thought, wow, mining companies, they have lots of money, so they'll be keen to do lots of verification and be really sure about their stuff. Well, it's not true. Mining companies are very happy with 1 to 3 plots in 100 hectares, which is not really representative. And therefore, UAVs are a nice way to extrapolate what we might find in 3 plots that are close to a road. Anyway, this transect had been measured for 10 years, and because generally you don't wander around too much, you just go into your transect and out. First thing we notice is there's actually a sizable gully there. We have a look at the gully, work out, well, how good is this work. We put in some paint marks on this gully, so we can measure it and measure depth, width on the ground, and then actually do it with the imagery and the digital surface model that is developed from the imagery. Now remember, it's a surface model, so it's really just using imagery, so if a gully is hidden by leaves, we won't be able to see it, as compared to LiDAR, which is enough points that will get through vegetation, and it's really dense. So we demonstrated, whatever year that was, 2014, that yes, this technology is good. You can find gullies, you can tell them how much gully erosion there is. If you want to fill it with rock, or you want to spend money on it, we can quantify how much money you might need to spend and how much material you need to pull up. And the depth on the ground versus what was developed in these digital surface models, there's a few points, they're okay, they're related, relatively simple. It was really just to demonstrate that it could be done and that it was a good way to inform what sort of maintenance activities needed to happen on site. Additionally, so this is one site which is about 20 years old when this image was taken, and I'll talk a bit more about why it's such an interesting pattern a bit later on. And those are the 3 transects that have been monitored over 10 years. and gave one answer. And if you actually categorise it all and look at how much bare ground there is bare ground an issue? Generally, bare ground leads to gully erosion. We can categorise the whole polygon that they're interested in and give them an assessment of what's happening in that polygon area. So, in essence, that set of remote sensing data allowed us to give the companies transparent, comprehensive data sets that were much better than the 3 plots that used to be used, actionable information, a bit more efficient time for use of field labour, and also gives the regulators also some idea of whether an area should be certified or relinquished, or just build up the evidence that it's good or bad. So this led into a new project with ACUP, which is Australian Coal Association Research Program, which I've had several of their grants, so I should know their acronym, but you just know that. Yeah, that's it. And we tried applying not only the UAV imagery, but also trying to work out a way to come up with a rule set that could be used at a site. And we had 4 test sites: Ivanhoe North, Meandu, Curragh and Oak Creek, to try this out. Now these are what, we didn't do across the whole site, we were just still developing techniques, so the areas range from, say, 100 hectares to, about 300 hectares. And different, and there's some, we collect them 2 seasons over 3 years. And then we applied, and of course, as this happens, some sites don't want you to use your drones, they want to use their own. So at Oak Creek, they had their own, and it is different to what we use, and it only collects red, green, blues, which is just standard imagery. Swamp Fox, which is that one there, we have red, green, blue plus near infrared. The new 1 year we use Swamp Fox, next year I lost all my staff who helped me fly, so I went to the single-use operator, EB, and also we have red, green, blue and near infrared in all of this. So just by the shift of time and the evolution of personnel and technology, we get a change in actually what our output is, which is one thing when you're using a technology that is rapidly changing. And sat down with the different company representatives, said, okay, what criteria from this imagery is meaningful to you and you would consider success or otherwise? So we won't dwell on it too much. Do you see a problem with greater than 1,000 metres of bare ground? Yes, that's a problem. So most of the sites 1,000 metres, well, it's either 1,000 metres, 500 metres, depends on the site. Some you get a lot more rainfall, some are a bit more patchy. And don't worry about it, they're all relatively similar, some have a bit more nuanced. And then we tried to, so with that data set, then we tried to use something called object-based image analysis. So there's a program called eCognition, which is well known and it's used for classifying particularly landscapes. Generally hasn't been applied too much with very high resolution imagery, so good at capturing houses and roads and things like that. And we thought we'd apply it to on-site rehabilitation. And so by using that software and that rule set, we can come up, well, not that rule set, but also just a rule set using digital surface model. You can also get a digital train model, which is sort of a composite piece. You can look at how high trees are, you can make some assumptions, and then you get this classification which the computer spits out, and hopefully it's generalizable across different sites. Of course, it's not perfect because you've used different data sets and there's different nuances. Anyway, so this is the same site that I showed you previously, and you can see grass also picked out some gullies, and there's some steep areas which I consider bad, and trees which are too over 4 metres. And similarly, this is Meandu and then Ivanhoe North, where they have a lot more woody debris on the ground. And from that, then we can say, okay, so category 1, we can give you this is what lots of sites like. We can give you a stop-go, or we can give you, is the site safe, stable and sustainable? Would be category 5 and nice and green. And this, we didn't find any that were that. And this site was near, and that means they didn't reach any of those categories that I had, or criteria that were on the page before. So either we're too prescriptive, and maybe things aren't as bad, or there's some work needed. And it's a way to get them to investigate whether there is work needed, if those criteria, which they help set, were acceptable or not to them. And so across the 4 sites, we did it over a number of seasons and gave them a snapshot of where we thought their rehab was according to their criteria. I don't know whether everyone's happy with me, but that's okay. Now from this, at the same time, we also had the ability to talk the site into burning Curragh, and because when you try and sign off your rehabilitation, one thing that always happens to Australian vegetation is it'll undergo drought, and it's more likely than not to have a fire. So if you want to hand it back to someone, then you might need to demonstrate that it will survive, and the landform will survive after fire and after drought. I don't have any control over drought, but we do have control over fire. So we convinced these guys to have a fire, and all was well, we hoped. So you might remember this site again. What happened was this site had 2 different types of rehabilitation. One was 100% topsoil, and with topsoil you only get grass. Then they had a second style of rehabilitation, and that's where they put spoil in 10 metre wide strips and topsoil in the other 10 metre strips. So you sort of have something resembling a golf course. And in the spoil they would sprinkle tree seeds, and the trees would stay there. So you can see there these lines of trees, whereas over here where it's full topsoil is generally just grass. And so up there you can sort of see blue is grass and open woodland is the other. And so with historic imagery, this is what it looks like on the ground when they were putting in. And if we zoom in close, you can see from the UAV imagery, this is all topsoil, these are the strips. You can see some of the strips 20 years on are still there, and that's where the trees pretty much lie. There's definitely a few acacias popping up there. And so then we convinced them somehow that burning the rehab is a good idea. On a coal mine, of course, people don't like fires. I'm not sure exactly why, but they don't. But people do like fire, so somehow the two met. And so this is a good training exercise for your fire people. They went, oh yes it is. And so we burnt it all in a matter of a day. And so the fire started on the leeward side, wind was from the south, this was in May, and went around and all was well, didn't really escape. And that's what it looked like on the ground. And there were lots of birds that come in, which is, there's some theory about birds actually burning sticks and starting fires elsewhere. And indeed there are lots of birds, but I haven't seen any birds taking sticks yet. And that's what the buffer grass looks like beforehand. There's a little acacia here, keep an eye on that. That's what it looks like straight after the fire. This area is obviously pretty flat. And up in the corner here, we also have biomass. So before it was about 12 tonnes per hectare. After fire, obviously not much at all. And this is on the transects. It's an average value for the. We had 5 transects for different grass community and for the tree community. And there's not much more biomass. A little bit green. 3 months afterwards. 6 months after, the people started worried because it really was alive. They haven't any rain, and the biomass is doing nothing. And then, of course, the summer rains came, and buffer grass being what it is, it came back happy and greener, less thatch, and biomass is jumping up. And then you can can see the acacia here is popping out, and it's back at the biomass levels that it was prior to the burn in the grass area. And this is with no rainfall. This is what buffer grass does. It comes out and it seeds before there's actually any rain. It's quite amazing as a species. And so both in the grassland community, which was up there, it came back. The open woodland community is actually higher in biomass post-fire. So that's all good news, and I'm not presenting it here because for essence of time, but also species diversity, which is important to ecologists, increased as well. So fire was good for this ecosystem generally. And there's just some of the UAV imagery over that time, and red because we're using false colour where you use the near-infrared band, which gives you an idea of vegetation health instead of the red band. So things look red means nice and happy plants. And for some reason, a lot of those didn't come out, but there's a bunch of different indexes that can be used with the different bands that you have. So red, green, blue, near red, and you can come up with different combinations. And before, there were lots of nice equations there, which I'm sure you're sad that you're not seeing as engineers because those are important to you. Sorry, you can come and talk to me later. In the end, the excess green index worked best. And so if you imagine before, you do a pre-fire, 2 times green band minus red minus blue, and you get values from high to low. This means high is good. Post-fire, you can develop the same. See the high is much lower, and then you can get a difference between the two, pre and post, and come up with a severity map for the site, which is nice for us. Mine doesn't really care too much, but we can estimate how severe the fires were, and if you want to do it at a regional basis, the people who control fires like to know how severe their fires should be expected, because there's actually not any models for buffel grass in Queensland, even though it is now one of the dominant grasses. We have lots of models for native grasses, native forests, but not buffel grass. So Queensland Forest Fire Service was very interested in this data and are continuing to work with us. Now, there's just a close-up of index. Generally it worked well. Red is severe, and sometimes it worked poorly, as you can see some of the white now. So it's not perfect, but all the indexes aren't perfect. This data led to us convincing a whole bunch of other mine sites and ACARP that burning is fun and burning is good, and more sites should do it. So this year we've started a new project, burning fire on mine sites across multiple sites. The thing is, they weren't that interested in funding drones, and I'm not sure it's because they hate me, so they didn't want to fund the drone part, but that's all right. The sites that wanted to burn have so far agreed to pay for my time to fly the drones, because otherwise it'd be just a standard, we'll go do some transects and monitor fire severity on the ground. It doesn't have the novelty. We did burn at Newlands, I think it was in July, and they decided to do a night burn because night burns are lower risk, even though you can't see anything, you can see the fire. It worked fine. With the new drone, I have nice thermal imagery, and so even though it's a night burn, I can fly and we can look at rates of spread and how severe, because of course it's all, you know, what the temperature of the flames are from the thermal camera, or at least up to 550 degrees, I think is the sort of maximum. So we did that in July, and then I think it was last month, Ensham called up and said, oh, we're going to have a fire next week, can you come? And we said, sure. And so they had their fire during the day, and again, you can see this thermal imagery versus the daytime imagery, and it's interesting how the different mines. Ensham is not owned by a big corporate, so they actually have farmers like fire. Corporate, you know, the occupational health and safety guide directs everything. They check it for 3 days, make sure all the fire's out. This site, they pretty much go and have tea at lunch, or they have lunch, and then go back and have a quick check in the afternoon. All's okay. So different levels of interest and worry about fires. Because this site, Ensham, is actually very much designed to go back to grazing, and probably is more successful because they have nicer soil, and even though it's on slopes, it seems to be staying pretty well. So, fire and rehab. So, rehab method, it does have an effect on fire and recovery. It's on soils, depends what they did. We know that when it's unmanaged, which most of the Bowen Basin rehab is unmanaged in the sense that it's created and there it is, that could equal high risk in the long term, because there's a lot of, buffer just sort of sits there and grows and thatch builds up. It's designed to be grazed by cattle. We did demonstrate that the rehab that we've looked at thus far is pretty resilient to fire, and at least the remote sensing indices, depending on what you want to use, they all operate in a similar way. And so I'll finish, because I'm out of time. I guess the key opportunity for drones currently is that they do reduce the risk getting people out of the field, which, as I've said before, often field work can be, you can't always see tunnel erosion, you can't always see gullies because they're covered in grass. So very nice to get people out of the field and still have a greater overview. They also provide great visual and geospatial data. So regulators really like pictures, so that's great. And also, you've got real evidence behind, which is correlated with on-the-ground measurements. And they give another way to demonstrate that the vegetation communities that these mines have created are resilient to fire, but over long term, because you can look at temporal change quite closely. And finally, also because people still think they're sort of cool and must therefore be useful, which I will continue to portray as long as research money comes my way. So that sort of rhymes. And I think that's where I have it. Thank you.